Okay, this is what we do in year 11, how to balance complex half equations in acidic conditions. In year 12, we'll look at how to do it in basic conditions as well. So what you're doing is balancing it when you've got more than one element, and you have to balance all the elements that are there and the charges. So the example that we'll use is nitrate ion going to dinitrogen monoxide. Okay, so first thing, have to make sure that you balance all the elements other than oxygen. So in this case, you've got nitrogen. So you've got one nitrogen here and two on this side. So the first thing that you have to do is make sure you've got two on this side by putting a large number at the front. That's what we do with all the balancing. Okay, so then we have to balance the oxygens by adding water. Okay, so we've got two lots of three. We've got 6 oxygens over here and only 1 over there. So we need, we've got 1 oxygen, we need 5 more. Each water molecule has 1, so we need 5 water molecules. By adding the water, we've now added hydrogen. So we've got 10 hydrogen. So we're going to have to balance the hydrogen by adding hydrogen ions to the other side. So we need 10 hydrogen ions. And then the last thing we need to do is balance the overall charge by adding electrons. So you can see we've got 2 negatives on this side, 2 nitrates, which are negative. So we've got 2 negatives, 10 positives on this side, and no charge on the other side. If we add these charges up here, 2 negatives, 10 positives, overall we've got 8 positives on this side. So we need to get rid of these 8 positives, so it's the same as the other side. So if we add 8 negatives to this side, 8 negative electrons, then that'll cancel out the 8 positives that we have here. So it's the same charge on both sides. This is the easiest way, I think, to balance the charge, to work out how many electrons you need by balancing the overall charge. The other way that you can do it is with oxidation numbers. So if you worked out the oxidation number for nitrogen here, it's -2, -6. 1 left over, so it'll be +5 that you would need, so it's +5. This one's -2, -2, +2, got 2 of them, so it's +1. So each nitrogen has gone from +5 down to +1, okay, each nitrogen. So you need to add 4 electrons for each nitrogen to change. Because you've got 2 nitrogens, you're going to have to add 4 each, so you need 8 altogether. I think oxidation numbers is a little bit trickier way of working out how many electrons, but if you had to, you can use oxidation numbers. Alright, so we've just looked at one half equation, balancing it. If we looked at an example, when a pale green solution containing Fe2+ ions is mixed with a purple solution of permanganate ions, the purple colour disappears because you've made iron 3+ and Mn2+, manganese ions. So we need to write the half equations and then balance the overall. So the iron has gone from Fe2+ to Fe3+. So it's gone from 2+, iron become more positive, to 3+. It's become more positive. It's lost negative electrons. So it's undergone reduction. No, sorry, oxidation. Oxidation is the loss. So the oxidation is the iron, and that's the easiest one to work out. So oxidation is the loss. Remember to add the electrons to the correct side. You've got 3 positives here. You need to have that the same as 2 positives. So you need to add a negative to bring it down to 2, so the electrons have to be added to this side. So 1 negative, 3 positives, overall is 2 positives. So oxidation is fairly easy, so clearly this is reduction. If we do it with oxidation numbers, we can work it out. So oxygen's -2, -8, we've got 1 left over, so it has to be +7. You've only got 1 manganese, so it's +7. So it's gone from +7 down to +2. So clearly the manganese has gained 5 electrons. So you know that you would need to be adding 5 electrons here. The other way of doing it, apart from using oxidation numbers, is the way that we did before. First thing you need to do is everything other than the oxygen. So you've got 1 manganese, so you don't need to do, there's 1 manganese on both sides. The oxygen, you've got 4 here, so you're going to need to add 4 water molecules to balance the oxygen. Because you've done that, you've added hydrogen, so you're going to need to add 8, 4 lots of 2, 8 hydrogens to this side. Then if we do the overall charge, you've got 1 negative on this side and 8 positives. So overall on this side you've got 7 positives and you've got 2 positives on that side. So we need these charges the same. So if you've got too many positives on this side, if you add 5 negative electrons, then it will balance. So that's the overall. Why did I write it again? Okay. So the overall, we need to put these two together. So this reaction loses 1. This reaction gains 5. So you have to do that first reaction 5 times. Everything on the left you collect and write it out. Just remember, when you go 5 lots of iron on this side, don't forget to do 5 lots of that iron on that side. People always forget to do this 5. Cancel them out, so get rid of the 5 electrons from both sides. Is there anything else that we can cancel out? No. If you put 2 complex half equations together, you probably get water on one side and water on the other. So you'll be able to cancel out the waters and the hydrogen ions, so that you just have them on one side.